So let's solve the question. The first step is that we must factorize the denominator, but in this question, the denominator has already been factorized, so we don't need to do anything. The second step of the solution is that we need to identify the types of denominator factor. Is it case 1, case 2, or case 3? So the front denominator is case 1 because the denominator is a product of different linear factor, while at the back, which is the x squared plus 4, is case 3 because the denominator contains an irreducible quadratic factor. The third step of the solution, write the given function into a partial fraction decomposition. Based on the question, we already identified the types of denominator factor, which is case 1 and also case 3. We must use alphabet as a constant for their numerator. So which means for the case 1, it will become a over x plus b over x minus 1. For case 3, we'll be using cx plus d over x squared plus 4. And cx plus d is actually a linear. Next, we must multiply the numerator with the denominator so that we can cross out both of the denominator from the question and also from the partial fraction that we did. After that, expand the equation until it becomes like this. Then, rearrange the equation so that it will be easier for us to factorize. Factorize all the x in the equation, so it will be the fourth step of the solution is to determine the values of the coefficient a, b, c, and d. Next, I will show you on how to do the comparison method. To do the comparison method, we must look at the x on both sides of the equation. So, the first comparison is I will compare negative 4a with negative 4. So, this is the first comparison. And we will get a equals to 1. Next, I will compare 4a plus 4b minus d with 9. This is the second comparison. And we will get the equation of 4b minus d equals to 5. But I made d as a subject so that it will be easier for me to do the substitution later. So d equals to 4b minus 5. The third comparison is I compare a plus b plus c with 5. So, this is the third comparison. And we will get the equation of b plus c equals to 4. But I make b as a subject. So, it will become b equals to 4 minus c. For the fourth comparison, which is a negative c plus d will equal to 0 because on the left side of the equation there is no x to the power of 2. So this is the fourth comparison, and we will get negative c plus d equals to 1. But I make c as a subject, so c equals to d minus 1. Next, we need to find the value of b, c, and d because we already find the value of a, which is equals to 1. So the next step is I will insert the equation of b into d. So it will become d equals to 4 times 4 minus c minus 5. So we will get another equation which is d equals to 11 minus 4c. Next, I will be using this equation to find d. So I will insert the equation of c from this one. So it will become d equals to 11 minus 4 times with negative 1 plus d. And we will get d equals to 3. After that, I will be using the equation from d for this one. Because we already find the value of d, so we will just insert d equals to 3 equals to 4b minus 5. So we will get the value for b, which is 2. So from this one, we already get the value of a, b, and also d. So the last one is we need to find the value of c, which is by using the equation of b for this one, we will get c equals to 2.
Other than comparison method, we also can use the substitution method. As you can see, when x is equal to 1, we're going to substitute the value of x is equal to 1. So when we substitute the x is equal to 1, we will get b is equal to 2. Okay, same goes to when x is equal to 0, we can get a is equal to 1. Then, okay, we're going to when x is equal to negative 2. We will not get the value of t and c here, but we got the equation number 1 here. Okay, same goes other when x is equal to 2. Okay, we will got the equation number 2. So when we got the both equations, we can make it the elimination method to get the value of t and also c. Alright, so first we're going to eliminate one of the variables, whether d or c. So firstly, if you can see, it is become more easier when we eliminate the c, because you can see the different signs there. So to eliminate it, we're going to make it become same value of variable. Like we're going to multiply 4 with the 3, so it will get the 12c. So when we multiply it with the multiplied by 3, every equation 2, we're going to multiply it by 3 too. Alright, then we can get the equation number 3. Okay, next, equation number 1 plus with the equation number 2. So the 12 negative 12c plus 12c, we will you can eliminate it, so you can get the value of t. Okay, so the value of t here is the 3. Alright, when you got the value of t, you just replace the value of d, which is 3, in the equation number 2, then you will get the value of c is equal to. That's all.
The last step is integration part. So first, we need to conclude the equation by substitute the values of a, b, c and d, which a is 1, b is 2, c is 2 and d is 3. After that, we integrate the equation and we split the equation one by one to find the values of each equation. So for first and second equation, we will use ln. The third equation we use u substitution, and the fourth equation we will use differentiation inverse function.
The integration of 1 over x dx will equal to ln modulus x. Next, the integration of 2 over x minus 1 will equal to 2 ln modulus x minus 1. While for the integration of 2x over x squared plus 4 dx, we will use the u substitution method. For the u substitution method, we must let u as x squared plus 4 and du will be 2x dx. So dx will be du over 2x. Next, integration of 2x over x squared plus 4 dx will be 2x over u times du over 2x. Next, we can cancel the 2x and that makes the equation integration of 1 over u du. And we replace back the u. So the result is the equation will be integration of 1 over x squared plus 4 du. And the integration of 1 over x squared plus 4 du is ln. epsilon modulus x square plus 4 plus c. So for the last equation, which is the integration of which is the integration of 3 over x squared plus 4 dx, we have to let u equals to x, and that makes du over dx equals to 1, and du will equal to dx, and let a equals to 2. Okay, so to integrate the equation, we must take 3 out of the integration symbol, and that makes 1 over u squared plus a squared du. After integration, we will get 1a tangent inverse u over a plus c. For the final answer, we will get